So hi guys, so today I'm going to take current electricity entrance questions. So let's see that. I think you're able to all see the screen now, correct? Yes, so for a better bandwidth, I'm just switching off my video. Yeah. And if hope everyone is comfortable with the current electricity. So I'll just see whether you guys are able to do this question. Fifth question. I'll just give a time of 1 minute for this question. Okay. I want everyone to just try this and let me know. Question number 5, please try. 10. Okay. 10 ohm. Okay. One answer I got is 10 ohm, which is obviously there in the option also. Ten. Okay. So two of them has given me the answer as 10 ohms. I'm just waiting for units to tell me the answer from her end. Okay, not sure. Okay, fine, fine. See, if it's a Wheatstone bridge, then I can clearly say that it is 10 ohms. Okay, but since it is not a Wheatstone bridge, then I can't say. So for this, before doing this question, let me take the whiteboard here. I think it's still loading. Yeah, I think the Zoom has crashed now. 1 second. Yes. I think you should be able to see my screen now. Yeah. Is everyone able to see the screen properly? Yeah. Are you able to see the screen, everyone? Screen is visible for everyone. Yeah. So I'm just going to do on 2018 entrance paper. I don't remember whether 2018 or 17, but this is the example which I give for all the students. Let me check. I think you can see this thing, right? Diagram here. Not up to the mark. Let me just draw it neatly, because this new Zoom thing, it's not like the old one. Let me just take the laptop and I think now I will be able to get it properly. So these are the resistances here. So resistance between A and B. So this I'll give 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm. So calculate the resistance between A and B. Calculate resistance between what? A and B. Okay. So what I want to tell you is, can you see this thing? This one? This is a junction actually. This is a junction, right? Similarly, this is also a junction. Correct? Yes. So if I want to talk about junction here, let me change the color, then it will be easy for you. In this particular junction, the current can enter how many ways? 3 ways. The current can enter 3 ways. So in a junction, current can enter 3 ways, right? Is my marker visible to everyone? Is it visible? Ali, what about now? Is it visible for you? What about others? Are you able to see what I'm drawing? 1 second, Ali. If that is the case, I'll just close this whiteboard. Okay, and I will just do a share screen on this video. I'll just zoom this thing. So is this thing clear to everyone? Is this page clear to everyone? Yes. This page is clear to everyone, right? Yeah. Perfect. See, same question what I want to draw is this one. This is my A, this is my B. This is my 1 ohm, 2 ohm, 3 ohm, 4 ohm, 5 ohm. So I'm not wasting time by drawing ohms. What I want to tell here is, see, this is the junction here. Let me just draw the junction here. This is my junction. Current can enter how many ways? 1, 2, or 3 ways. Correct? If I take this junction, current can enter or leave. How many ways? 3 ways again. Correct? So in a junction, if a current can enter 3 or more ways, then it is parallel. Then the resistance are in parallel. If the current can enter in 3 or more ways, the resistance are in parallel. If I take this junction, current can enter in how many ways? 2 ways. So if it's 3 or more ways, it is parallel. If it is not that case, then it is what? It is series. It is series. So this 1 ohm, this 1 ohm, this 1 ohm and 2 ohm are in what? Are in series. This 1 ohm and 2 ohm are in series. Because this is a bended wire. Here current can enter only in how many ways? 2 ways. Because we know that if it's 3 or more ways, it is what? Parallel. Else series. Else, I'll write down here. Else series. So this 1 ohm and 2 ohm are in series. So 1 plus 2, 3 ohm. Correct? And this 3 ohm is parallel with what? Another 3 ohm. Correct? It's parallel with another 3 ohm. Then this is 4 ohm and this is my 5 ohm respectively. Again, if I consider here the junction, correct? 3 ohm and 3 ohm are in parallel. If the resistance value is same and if it is parallel, then I'll just do what? R by 2. So what is the value of this 3 by 2? 3 by 2 is 1.5 ohms. So this is equivalent to 1.5 ohms. This is my 4 ohms and this is my 5 ohms. Now if I take the junction here, now if I take the junction here, correct? If I take the junction here, these three are in what? Series. Because here the current can enter in two ways. So 4 ohm is in series with 1.5. Here also current can enter in two ways. So 5 ohm and this. So 4 plus 1.5 plus 5, 10.5 ohms is the answer for this. Is it clear for everyone, this concept? Is this concept clear for everyone? Three or more ways in the junction, it is parallel. Others, it is series. So only one yes, sir, I got. That is from Ali. Eunice and Aman, is this concept clear? Yeah. Eunice, okay, fine, perfect. What about Aman? Doubt is there? Very simple concept only. Yes. So with this, let me just clear everything. Okay. If whiteboard is a problem, then with this, what is it actually here? The same concept if I'm doing here, 10 ohm and 10 ohm, 20 ohms series. 10 ohm and 10 ohm, 20 ohms. Correct? Then what is this part? This is a junction. Current can enter how many ways? Three ways. If it is three or more ways, what it is? This 20 ohms is in parallel with 10 ohm. What about current here? Current can enter how many ways? Three ways. Yes, it's a junction here, no? Current can enter this junction three ways. Current can enter or leave this junction three ways. So this 20 ohm is in parallel with what? 10 ohm is parallel with another 20 ohms. Is this thing clear to everyone here? Is this thing concept clear to everyone? And can you try it now? Three of you. And tell me what is the answer. Yes, I have just muted myself. Yeah. So 5 ohm is the answer. Correct. Only in Wheatstone bridge, the resistance value will be same. The resistance value will be same for the Wheatstone bridge. Okay. Now let me, as I told about Wheatstone bridge, let's see any question related to that is there in this particular paper. If it is there, then I will do that question now. Yes, I think I got one question. Question number 19. The Wheatstone network is shown. If the key is closed, the galvanometer will option left deflect on the left side, deflect on the right side, deflect on the other side, does not show any deflection. Yeah, which is the option for this question? A, B, C, D. What do you think is your answer? Correct. One correct answer I got. You just don't need to worry. You can just tell the option. Okay, whatever you feel like, you can tell it. We have to make mistakes. So if you don't know, you can tell me you don't know also. Maybe that concept might not be clear. Yes, correct. Option D is the correct answer. Guys, 1 minute. One of the students is unable to join the meeting. I'll just help him out. So option D is the correct answer for this. Because the key is closed. Correct. If the key is closed, then the galvanometer will show no deflection because the Wheatstone bridge is said to be balanced. So option D is the right answer for this. Question number 1. The resistance of wire in a heater at room temperature is 65 ohms. Okay, so these kind of questions, who hasn't done, let me know in the chat option. Not done. Okay. Yeah, fine. See, there is a simple formula for this. I'll write here only the formula. Because if I go to whiteboard, I think most of you are unable to see it. Correct? Yeah. Yes. So the formula here is nothing but R2 minus R1, alpha. Okay. There's a relationship. R2 is equal to R1 into 1 plus alpha into what? T2 minus T1. How many of you have seen this formula at least? So this alpha is nothing but temperature coefficient of resistance. Okay. Aman knows it. Yeah. So this is there in NCERT textbook back question, that is in current electricity chapter. Okay. R2 is equal to R1 plus R1 into 1 plus alpha into T2 minus T1. So multiply this R1 inside the bracket. Correct? So what I'll get? So what they are asking in this question? What is the steady temperature of the wire? Correct? What is steady temperature of the wire they are asking? Clear? Yes. So first thing is, what is my T2 minus T1 from this formula? T2 minus T1 is equal to, I'll write down here, T2 minus T1 is equal to what? R2 minus R1 by R1 into 1 by alpha. Okay, I'm just rearranging the stuff here. That's all. What is my resistance to? What is my R2 value? R1 value is given 65 ohm. Correct? Yes. How do I find R2? Just draw the triangle V is equal to IR. V is equal to IR. Correct? So what is R is equal to V by I? What is my voltage given? 220 volts. So 220 divided by current is 2.8. So once you solve this 220 by 2.8, I'll be getting 78.6 ohms. That is my R2. My R2 value is 78.6 ohm. Simple V by I formula. Then substitute here R2 minus R1. Alpha is already given. I'll be getting T2 minus T1. Correct? T2 minus T1 I'll be getting. Okay. Yeah. So once you solve this, what is T2 minus T1 value? That you have to calculate and tell me. So no need to do the full thing. Once you get T2 minus T1, just mark the closest answer in the option. That is the best way to do in entrance. Okay, because in this question, what is not given is what the T1 value is not given in this question. That is taken as standardly 27 degrees Celsius. 27 degrees Celsius. This is standard value. Suppose if you are not able to remember T1 value is 27 degrees Celsius, T2 minus T1, once I get the option, mark the closest one. I'll be getting 1231. I'll be getting 1231 as the value of this R2 minus R1 by R1 into 1 by alpha. Okay. Yeah. So let me clear this. I think if you have got doubt, once the class is over, I'll help you out with this. Two bulbs when connected in parallel, you can just do what? 60 into 60 by 60 plus 60. You'll be getting the option for this. So just divide by 2. So 60 by 2 is 30. That's it. I told you if the values are same in parallel, just do by 2, R by 2. That's more than enough. Yeah. And third question. The IV graph from two different electrical appliances are shown. They are saying that resistance, RP and RQ of the resistance is what? Is it equal? Correct? So those things they are asking. So first thing is we have to use elimination technique. Elimination technique is what? Removing the wrong options. We know that P and Q can never be equal. So cut this thing out. Option A is deleted. RP is equal to RQ by 2. We don't have any mathematical derivation to prove this thing. So this has also been out. Only two options are there with us, whether RP greater than RQ or RP less than RQ. For this, what we have to do is, in our chemical kinetics chapter of chemistry, correct? First order, zeroth order is there, right? For that, what we find? Slope we find out, no? Correct? So the slope. What is my slope? Tan theta, dy by dx. Gradient. Different name of slope is or slope. Dy by dx. Gradient. Tan theta. Correct? Yes. So these are all the names of what? Slope, respectively. Correct? So if I take this as theta 1, and if I take this as theta 2. Yes. Which angle is greater? Theta 2 is greater, right? Bigger angle is greater, obviously. So tan theta 2 greater than tan theta 1. Correct? What is my slope here? What is this graph? I by V graph. I by V graph. So V is equal to IR. Correct? VI graph. Yes. So what is my tan theta? What is my tan theta here? Tan theta 2 here. If I take the bigger graph, it is the resistance RQ for this. Correct? Bigger graph slope is what? 1 by RQ. Correct? Because I know that tan theta 2 is greater than tan theta 1. This is 1 by RQ greater than 1 by RP. So RP greater than RQ. Option B is the answer for this. Option B is the answer. Okay. So now I'll come down and I'll help you with all the doubts and we'll do much more. Fine. I think everyone can exit the meeting now. Thank you.